Alright, here's another look at a potentially ambiguous case. We did this, you probably saw this just above, that we did this question where AB was 3 centimeters and ABC was 30 degrees, and then they told us that the remaining side was 2.5 centimeters long. They've changed exactly one thing in this example, and that is the length of the leftover side. Instead of 2.5 centimeters, it's now 4. Let's see if that makes anything neat happen. So, 3 centimeters, 30 degrees. Again, we know that the third corner, C, is somewhere along this line, but we have no idea where. It could be way in here, up here, up here, up here, up here. We have to locate it and then figure out the rest of the information about this triangle. Now, I suppose we can eyeball this a little bit. No. I was going to say we could measure out 4 centimeters and get a general idea how this triangle is shaped, but let's keep the suspense on for a little longer. These steps that they're having us do will reveal that to us. So, we have C. It's somewhere along this line, not sure where. We don't know what angle it is, but we can say that sine C over, where's side C? Side C is across from that, which is the 3 centimeters, equals the sine of angle B, which is 30 degrees, over, and the 30 is across from side AC, and they tell us AC is 4 centimeters. So if you solve that, you get sine C is, it'll be 3 sine 30 divided by 4. So from that I get sine C is 0.375. Just going to run that again. Yeah, good. Okay. So sine C is 0.375. If you do second sine of that amount, or arc sine, you get a reference angle of 22 degrees. Now you remember what we were doing before. We said if sine C is 0.375, that tells us it's positive, meaning we could be in this quadrant or this one. Our reference angle is 22, either there or there. And so what angles could we have? 22 degrees, or this would be 180 minus 22, which is 158 degrees. Now, only one of those angles is actually valid. Do you see why? One of them is impossible. Not impossible in the general sense, but impossible for this triangle that we've begun to build. Another hint, it can't be the 158. Why not? Pause this if you want more time to think, because I'm about to give away the answer. There's only 180 degrees in a triangle. This one already has 30 degrees committed for this corner, and now we're talking about putting another 158 degrees in there. That puts us over budget on degrees. That's 188 degrees already, and we haven't even counted angle A. So 158? No way. Impossible. This one has to be 22 degrees, meaning it must be a triangle that looks something like this. 22 up there. That's our 4 centimeter side. There is no way that you can fit 4 centimeters in over here. There's not enough room. And so this one is not an ambiguous case. This is an unambiguous case, because with the measurements they've given you, there's only one triangle that you could possibly construct. So the measure of angle BAC down here would be, well, let's see, 180 minus 30 degrees leaves 150. Use up another 22 degrees, we're down to 128 degrees for angle BAC. So, in the previous example, we had two ways it could work. It could be 30 here, 37 here, and then 113 degrees. The other possibility was 30, 143, and 7. Both of those added up to 180, so there was no contradiction. In the current example, there we go. One of the answers, the sine law tries to give us two answers, but one of them doesn't work in this triangle, so we throw it out. And so for this one, we can confidently say that the solution is this angle is 128 degrees. There's only one thing that these measurements can mean. So when you're given an SSA triangle, where they give you a side, and an angle, it can be ambiguous. It can be ambiguous, but it doesn't have to be. You just have to keep track of your number of degrees and make sure that you don't go over. Triangles can have 180, but they can't have any more than that.